Hey everybody, we are doing the density lab. And so in this lab we're going to find the density of a hunk of copper, okay, and a hunk of aluminum. Notice they're pretty much the same size. Okay, the thing that's missing for you is to feel the difference. Okay, this thing is really light. If you've ever picked up an aluminum can, you'll know the difference, and this thing's pretty heavy, right? We're going to find four densities. We have two objects but four densities, and the reason why is we're going to find two densities for copper, because we're going to use two different methods. Two densities for aluminum, because we're going to use two different methods. Okay, we're going to measure the mass just once, but we're going to measure the volume by two methods. One will be by measuring it with the ruler and calculating it. And you can see right here, there's a cylinder, and we know the formula for the volume of a cylinder is pi r squared h. If you downloaded this form, you could see that. Okay, and the other method for finding volume is going to be by displacement of water. So we're going to fill some water in here. Okay, it doesn't matter how much you use, as long as it's enough to cover it. It has to be higher than this thing is tall, so somewhere up there. Put it in the water. The water level will go up. We subtract the difference, and whatever that is how big the volume of this is. And the units of volume, when you do density, are typically cubic centimeters. But remember, a cubic centimeter and a milliliter are the same thing. So the first thing we'll do is weigh this. Let's see, mass of copper, we'll throw this on here, okay, on the balance. And let's see, I'm going to slide this to 20. Let's see. Okay, so it's a little heavier than 20. Oh, it's actually a lot heavier. This thing's in the 30s. 40. How heavy is this thing? Okay, there we go. So okay, we're pretty close. And this balance has the ability to read to 1/100th of a gram. Okay, so actually a very precise balance for you know. And the other thing is, you know, it's not digital, right? But I like that. Just because a thing is digital and has numbers on it does not mean it's giving you the right value. Okay, let me just kind of go there so you can see that a little better. Okay, so we're almost on zero. What I like to do when I do this, it's a little heavy, so I'm going to slide this back. I like to hold it so it doesn't jump around on me too much, and just kind of scoot it back like that and let it go. Okay, so we're pretty close to 56 grams. Okay, and I went too far. Oh, I'm darn near close. I'm so close. It's probably like just move this to the next little line right there, and we're good. Okay, so 56.223. So this thing's 56.23 grams. I'll do aluminum, and then I'll hold this up so you could see them both. Okay, we'll put the aluminum on there. You can see it's much lighter. It doesn't even trigger this thing. So we'll reset this and just kind of move this until it starts. Ooh, it's pretty close. Okay, so notice how it clicks. In order to get a proper mass, you have to be able to see the number in the window. So see how that says 8 right there? If you're kind of in between like that, that's nothing. You can't have that. Okay, so let's, ooh, I'm pretty darn close. Okay, so this needs to go back to 7, and this needs to slide way over. So it's more like 17 point something. Okay, ooh, I think we got it. Okay, just a bit heavier. Right there. Okay, got it. So we're going to call this thing 10 plus 7, that's 17.96. 17.96 grams. So hold this here. You can see we have 56.23 grams for copper, and for aluminum 17.96. Okay, so I'm going to kind of continue to do it in that sequence: copper first, aluminum second. Okay, so what we're going to do now is we're going to do the anything with water last, because we don't want to get it wet till the end. Okay, so what we're going to do here is we're going to measure the height of the copper and the radius of the copper. Okay, and then there's a spot right there for you to show your work and to calculate. So pi r squared h. Okay, so let's do the height first. Okay, I'm going to take my ruler in millimeters, put it there, and I've got 5.1. So I'm going to call this thing 5.1, and this is centimeters. Okay. And the radius. Now doing radius is kind of difficult. Okay. So when you do radius, how do I find the middle of that? Okay. What I can do probably is go with diameter and divide by 2. Okay. So if I put it there, that gives me 1.2. So 1.2 over 2 is 0.6 centimeters. Okay, so now for copper you have the height here, and you have the radius there. All right, stripped aluminum. These guys are very similar, so I wouldn't be surprised if they were pretty close to the same. But let's see. I mean, within a millimeter. Let's see what happens here. So this guy is 5.0. Okay. A little different. The other guy was 5.1, so they're pretty close but not the same. Radius wise, let's see what we got here. Radius wise, again, this is 1.2, so divide that by 2, that's 0.6 centimeters. Let's show that to the camera. Okay, so for copper, height is 5.1, radius is 0.6. You could plug that into pi r squared h, and hey, look at significant figures. Okay, think about this. There's your mass. Okay, so you could already find a volume. So to find a volume, volume is mass. I'm sorry, you could already find a density. Density is mass over volume, right? Okay, so you're going to take your 56.53 and divide by whatever number you get here for that, and then round to correct significant figures. Okay, then we'll do aluminum, and you'll do that. Okay, so those would be 2 of your 4 densities. And then we do water displacement. You'll have some other densities. By the way, the actual value for density, and you need this for answering the questions that are posted elsewhere, is if you do this to super precise, much better balance, much better way of measuring volume. The actual density of copper is 8.96 grams per cubic centimeter, and aluminum is 2.70 grams per cubic centimeter. So if your answers aren't in that ballpark, maybe you did some calculation wrong, okay, or I did something wrong. All right, but I've done this lab before many times for years, and my numbers seem okay here so far. Okay, so notice in the data table your densities for copper. So mass over volume by displacement, which we have not done. Mass over volume by formula, which you can do right now. Okay, aluminum, same thing, displacement formula. So the reason why we're doing the formula one first is because now I'm going to get stuff wet. Okay, and once you get it wet, to dry it, you don't want to weigh it, right, if it's wet, because you're weighing water. Okay, so to do that, I'll do copper first. Okay, and what we have in our data table is volume of graduated cylinder empty. Okay, so now empty not meaning with nothing in it. What I mean is with a certain amount of water, it has to be enough to kind of submerge this thing. Okay, so it could be anywhere here as long as I write it down. All right, so I have a bottle of water. I'm going to do this off camera so I don't spill it on the data table. And I'm going to put some water in here. Good. Okay, so there's my water. Got a couple bubbles. Now, when you read a graduated cylinder, you read by the bottom of the meniscus, right? There's a curve here, and I can't really hold this in the camera and do it score on because I need to look at it like straight on with my eye. And you could see it somewhere above 50, but I'm not sure yet. Okay, let's see what we got. I'm going to kind of do this like this. And one of the things I don't like to really do sometimes is put it on a table and read it, because you don't know this table is flat. If this table might not be level. So one of the ways of doing it, if you don't have a level surface, if you hold it like this and you let gravity kind of take it straight down, that probably looks crooked in the camera because the camera's crooked. But see, if I hold it like this, it looks like it's straight, but it's not because the camera's crooked. I'm going to leave the camera as it is because I don't want to knock my tripod over. I'm now going to read this, and this says 54 milliliters. Okay, so what we mean by empty is 54 milliliters. And remember, a milliliter is the same as a centimeter cubed. Okay, we're going to put this thing in there, and the water level will go up. And if you subtract the two, that would be the volume of this copper disc cylinder. So a little something about this. Don't just drop it in there for two reasons. One, it'll blow out the bottom of this darn thing right here, and water will be everywhere. I've had that happen. Okay, students do that. And the other thing is water splashes out. If you lose water, your lab's messed up. So what we're going to do is we're going to tilt it. We're just going to ease this guy in. Hear it? Hear how hard that sounded? Imagine if I just dropped it in. Okay, so now you can see it's pretty close to 60. Let me read that. Get in a light here so I can see what the heck I got here. And it is 60. That's kind of nice. Okay, so 60. Okay. Shoot, we could do this in our head. 60 minus 54, that's 6 centimeters cubed. So that's the volume of the copper one. So now you could do the density of copper two different ways. You could take your mass, which is 56.23, and divide by 6, right? That would give you your copper by displacement. Then you could take your mass, 56.23, and divide by the answer to this formula here. I'm not telling you that. That's what I want you to do. Show me you can square. Show me you could use pi. Show me you can multiply by height. Okay? All right, and let's do aluminum now. So what I'm going to do is dump this water. Oh, I didn't bring a thing to dump it out. Yeah, I did. I got one of my son's experiments right here. He's been working with acrylic, doing various things. So I'm going to dump that out into this used glass. We'll take out the copper. Okay, see now the copper's wet. So we wouldn't want to weigh it. That's why I weighed it first. We'll just let it dry over there. Okay, we'll start over. We'll put some water in here and do aluminum. Okay. So I'll pour water in there. Okay, that's enough, I think. Let's see. Yep, that's enough to submerge it. Okay, and our level is, you can see it's between 30 and 40. Let me get a good look at it. So let's see, 35. That's 36. Okay, so empty, it's 36 milliliters. We put the aluminum in. Okay, and now it's 43. Yeah, 43. Okay, that's 6 centimeters cubed again. Well, that's not too big a surprise. These darn things are almost the same size as each other, right? When you look at them, here, let's dump the water out. Let's look at it again. You can feel they have different masses, but you can see they're almost the same size. And notice they are the same size according to the amount of significant figures we were able to get by this method. This method is not calibrated down to micromilliliters, right? It's just got little lines there. Okay, this is not the most precise way of measuring a volume. It is precise enough for some things. Remember that this lab is just as much about doing significant figures. It is about finding density. Okay, even more so. Okay, and notice how a lot of different things have different significant figures. Okay, so we have 4 there, 4 there. This guy's got 2. This guy's got 2. We got 1 now. Okay, so don't text me and ask me what are the significant figures for this lab. That's the question I'm asking you. Okay, if you're not sure about that, go back at all the problems we've done with significant figures. Okay, and I will present some more before you guys actually have to do this lab. Okay, so you're going to report 4 answers back. Density of copper, mass over volume, mass over volume with displacement. Displacement was 6. Mass over volume with formula. You still have to work out the formula. Now for aluminum, mass over displacement was 6 again because they're about the same size with this method. Okay, and then mass over formula, which you have to work out one right here. Okay, you could always pause this video and look at the numbers again. 56.23, aluminum 17.96, those are grams. 54, 60, subtract 6. For aluminum, 36, 43, 6. What's different here is the height of the copper is 5.1, radius is 0.6. For aluminum, it's 5.0, it's a little bit shorter, and 0.6. The densities, accepted values, and when we find our percent error, that's where we're going to use accepted values. is 8.96. So your answer here should be in the ballpark of, 9, right? Okay, and the accepted value for aluminum is 2.7. So your values here will be like, 3, right? I'm not saying it's 3. I'm saying it's not 5. It's not 1, right? You kind of know where you stand on this. Okay? All right. So that's it for this lab.